We are doing 5.3, concavity and points of inflection. And you know what I say every single class? It's review. We're not really doing anything all that new. And it really is, and I'm hoping that the more I say it, the more you'll actually buy into this. But what I'm trying to get you to see is that it's all connected. It's not a bunch of separate stuff that we're doing. It's basically a continuation of the same old stuff. And I think taking that approach hopefully makes it a bit easier. So if we have a graph that looks something like this, and we are interested in, let's say, this point here. That point we would call the inflection point. Inflection point, or I could say point of inflection, same thing, doesn't matter how you say it. And that is the point where the function x changes concavity. So it goes from concave up to concave down. I'm going to write that off to the side. So at this point, it changes from concave up. Does everybody know what that means? To concave down. Or vice versa. It could go from concave down to concave up. So basically it's like kind of like where it's changing direction. So looking at the graph, does that make sense? Kind of see what I mean that it's not new. It's just I gave you a new term, vocabulary, that you actually could have learned in the past, maybe. Okay, it's also where the second derivative changes sign. Don't worry, I'm going to show you with actual algebra so that you can make sense of it. But for now, you can just write that down, and maybe I'll properly write derivative so you can see it. So this happens when the second derivative of f of x equals 0. And we're going to call this the second derivative test. I said I was going to be lazy, and now I'm writing it all out. Find the inflection points. I'm going to put the s in brackets because it could be one, it could be more than one. It depends on the function we're working with. We're going to do f of x equals x squared minus 4x plus 3. Can I move this up? Are we okay to move on? Okay, so we get to apply what we were learning in this. So find the inflection points, and here is the equation that we are working with, or the function that we're working with. So the first thing is we want to find the first derivative. I've chosen one that's pretty straightforward so that we can focus on the concept and not get lost in all the messy algebra. But no, as always, you will have, rational functions and all sorts of things with chain rule, etc., etc. So you'll need to do that. But we know by looking at this that it's 2x minus 4. So it's pretty straightforward when we go through 2x there and minus 4 from there. And then we can take our second derivative from this, and we find that from doing the power rule here, that it's just equal to 2. Okay, so f of x has no inflection points because it is always upward facing. Upward facing meaning concave up. So if we were to graph it out, it would look like this. Let's try another one because it really depends on what is going on in the function. So we want to do the same thing, but this time we'll work with f of x equals x cubed minus 2x squared minus 5x plus 6. We want to take the first derivative, so we're following the same pattern. Maybe I'll even show the last one so we can get into the habit and notice that pattern and use that to help us. So again, 3x squared, when we go through that, when we do this, we get minus 4x. Here we'd get minus 5, and the constant would leave us with nothing there. And then when we go to find the second derivative, we would take the derivative here, or the power rule here, sorry, we would get 6x. Here we would get minus 4. And so, this time, notice the difference between the last one and this one. So I wanted to give you a little bit of variety so that you can see how this might show up. Notice how in the last one, our second derivative was equal to a constant. And then we decided that it's upward facing, concave up, and all of that stuff. So this time, we actually have a function. We have something to work with. So our next step, which didn't occur in the last example, is we set it equal to 0. And then we do the same thing that we always do, which is isolate for x so that we can solve it and find what x is actually going to be equal to. When I pull over this 4, I'd get 4 over 6, and I would simplify that. So I would see that my x value is equal to 2 over 3. So when we're looking for the inflection points, we take the first derivative, we take the second derivative. If we are able to, we set it equal to 0, and then we isolate. Now that we've done that, we want to test either side of our inflection point here. So when I take a look at what my x value is, I could pick whatever I want. I'm going to draw your attention to this part. So that was our second derivative. If I want to test either side and I have 2 over 3, I'm going to maybe start with 0, because remember how we talked about how if you can pick whatever you want, why not choose smart, easy numbers that are nice and easy to work with? So we can plug in 0 into our f double prime here. So we would have 6 times 0 minus 4, and it's coming from that equation there. So we would find that this is equal to negative 4, which is less than 0. So I know it's concave, oh boy, concave down. So it would have like that kind of a shape. Okay, so that's fine. I tested 0, then I have options of what I could pick, but maybe I want to keep things nice and easy. So maybe 1 would be a good one because 2/3 is in between those two values, so that works well. But it really doesn't matter. You can pick 2 or 3 or whatever you like. When I do plug that in, again here it'd be 6 times 1 minus 4, and we get this time, that's funny. I wrote 4 for my answer in my notes. What? It's 2, but I even have white out there. So I changed it to that. I thought I was feeling out of it today. I must have been even worse that day. Okay, so this is 2 is greater than 0. So we know that at this point, it's concave up. So it's going to be that type of shape. Do you see why I say that every day? We kind of just do the same things over and over again. In different ways, slightly different ways. And the truth is, so much of what we do, you could do without calculus. You could do it the old way, like using a lot of our pre-calculus tools or skills for some stuff, but we're looking at it from a different perspective. So if it goes from concave down to concave up, I just maybe very quickly, generally, I'm going to put it together to say it must be doing something like that. Make sense? Okay. And I guess at around this point would be our inflection point, which would be that 2/3 where it's changing direction. So good to know what it actually means when we physically look at it and see the visual representation on a graph. So really, the only other difference that we could have is that I could give you different types of functions rather than the ones that we looked at here, but it's the same basic principles. So we're going to take the first derivative, take the second derivative, set it equal to 0. That is your inflection point, what you get when you solve that. And then you test values on either side. And now, instead of getting the nitpicky little details with the table of values and all that stuff we did in Pre-Calc 12, we just want a general shape of what it's generally going to look like. And the max and the min won't be accurate and all the other stuff. But if we do need those, we of course could plug in values to help us to test to see where it is. But we're sort of shifting out of the stuff we did in pre-calculus and all the classes leading up to this, and we're kind of stepping back and looking generally at like big picture thinking and looking at patterns instead of the teeny tiny nitpicky little stuff. Does that make sense? So I feel like in some ways it's a little more enjoyable and manageable, hopefully. So I'd like you to work on page 229, numbers 1A. 2, you can do the even letters. Everybody know what I mean by that? Because it's kind of a weird thing. Like, how could letters be even? Like B, why did I choose even? You could do odd if you, just do half of them is what I'm saying. Like skip. And then also do 3, 5, and 7. Whoops. And 7. And that's it.